Hello everyone and welcome to your video lesson of physics, and in today's video I'll be showing how can you find acceleration in any given scenario. So you get a question about acceleration pretty much in every paper, sometimes 3 mark question, 4 mark question, and in obviously you get question in paper 1 as well. So as per the specifications, the syllabus of O-level, GCSE and IGCSE, I've compiled like there are 10 to 11 different ways that they can ask you a question about acceleration. So every year, whenever they ask you a question about acceleration, it has to be from one of these ways. And if you're aware of all of them, uh, there is no chance that you're going to get it wrong. So make sure you uh, go through all the types in all the different ways in which the question can be asked. So let's start by the prerequisites before we proceed to the actual thing, which is to calculate the acceleration. Let's take a look at the prerequisites. Now you should be able to define acceleration, should be able to know its standard unit, its standard formula, the SI unit, and you should be able to uh, describe what the quantities in the unit refer. So let us write the definition first. The acceleration is simply defined as rate of change of velocity. Or you can say rate of change of speed for an object moving in a straight line. And the only thing is, this is the standard definition, but you have to relate the this standard definition with the context. If they have given asked the question in some context, you have to answer in that context. So they say, "Oh, how do you define acceleration?" And then it was the case of airplane. They say, "How do you define acceleration of the airplane?" So you write down the same statement and relate it to that context. All right. But once again, that is an optional thing. Just to be on the safer side, you can relate it to the context. But the standard definition, you write it down, you get full marks. And the word rate, it means with respect to time. So the change in velocity with respect to time. So once you have written the word rate, it means you're already defining it with respect to time. You don't have to write with respect to time or per unit time after writing the word rate. No, that would imply you writing the same thing 2 times. Now the standard formula of acceleration is A, which represents acceleration, equals V minus U divided by T. We measure it in the unit meter per second squared. Now in the formula, V represents final speed or final velocity. U represents the starting speed or starting velocity. You can also call it initial speed or initial velocity. And T represents the time during which the velocity changes from V to U or from U to V. The time during which the velocity changes, that represents T. Okay, so this is the standard definition, the standard formula of acceleration. All right, so in the first type, which is the most straightforward one, you're given with initial velocity, final velocity, and time straight away in the question. Like question number 1, it states the speed of the car increases from 5 meter per second. That is your starting speed. You can call it U. To 20 meter per second. That is your final speed, final velocity. You can call it V. And the time during which the speed changes is 5 seconds. Then you need to find the acceleration. So we write down the same formula, the standard one. v minus u over t. In the next step, we simply plug the values. 20 minus 5 divided by 5, and that would be 15 divided by 5, which would be 3 meter per second squared. Okay, so this is the first way they can ask you about the question of acceleration. And how do we uh, point it out? Initial velocity, final velocity, and time would be given straight away in the description, and you'll be asked to find acceleration. Generally, the question is of 2 marks. Make sure you write down the formula separately. In case there's some error in the working, you get independent marks of writing down the formula. Right? This one has independent mark. Now, sometimes it appears that only one velocity is given in the statement, and obviously time is given, and the other velocity is not given. But matter of fact, both the velocities are given in the statement. One is given mathematically, like in terms of number, the other one is given descriptively. Like if I read the statement, the object, you can write the object accelerates from rest. That means the starting speed is 0 and reaches a speed of 20 meter per second. That means your final speed is 20 meter per second, and the time during which the speed changes from 0 to 20 is 4 seconds. You need to find acceleration. Write down the formula. Okay, then insert the values in the next step. So 20 minus 0 divided by t. Yeah, and t was 4 seconds. 20 minus 0, 20 divided by 4, 5. 5 meter per second square would be the answer of this one. How do they differ from the first type? In the first type, uh, initial velocity and final velocity are given in numbers, but in this one of the two, initial velocity or final velocity, is given descriptively. So it can be something like this: an object accelerates from rest, that means initial velocity is 0. Or sometimes the statement would be an object comes to the rest from a speed of 30 meter per second. So comes to the rest would mean your final velocity is 0. Or object comes to the stop, comes to a stop, comes to a halt. That would mean the final velocity is 0. Starts some rest means the initial velocity is 0. So that was the second type. Alright everyone, so let's continue for the type 3, in which you can be asked to find the acceleration. And in this type, you're asked to find acceleration, and you're provided with the value of force and mass of an object. And the formula that we use in that case is derived obviously from Newton's second law of motion, that says F force equals mass times acceleration. So F equals ma. Okay, that is your formula that we use in this case, and then you can rearrange it to find acceleration, which equals F over m. Then we have a sample question, which you can see on your screen. The mass of an object is given, so they have given you the value of m, 2 kilograms, and they have stated the value of force F 40 Newton. And all you need to find is the acceleration of the block. So you write down the formula once again: A equals F over M. Then you plug the values: 40 divided by 2, which you get 20 meter per second. Right? So this one basically was C, but without the point here. 20 meter per second. Whenever you're given with the value of force and with the value of mass, and you need to find the acceleration, you can simply apply the formula A equals F over M, and that gives you the value of acceleration. Alright, then you have type 4, which can be thought of as an extension of the previous type. So in this one, you're not only given with a single force, rather you're given with a combination of forces. And you're given with the value of mass, and you need to find the acceleration. So in this case, we use the same formula: A equals F over M. Now, since in this type, there's more than one value of force that is given, so you might be confused which value of force do you need to plug in the formula. Like if I take a look at this question, I've been provided with 3 different values of forces. Now, out of these 3 values, which force do I need to plug in the formula? And the answer is we have to use the resultant force. Matter of fact, the letter F here stands for resultant force. So even if you, just to be on the safer side and for your own uh, convenience, if you want to write resultant in the subscript, then it would be good strategy. You can write it down, because it should be clear that whenever we are using the formula A equals to F over M, F there stands for the resultant force. So when there's a single force, like it was in the previous case, there was a single force, so the resultant force would be just the same. But when you have a combination of forces, when you have more than one force, in that case, the resultant force might be a little bit different. So let's check it out. The question says, it might be that you may be having a box here, something like this, and the mass of the object is 2 kilograms. You can write it down here, 2 kilograms, and then you're applying different forces on it. Someone was pushing the box with a force of 40 Newton, and then another person joins and added additional force of 20 Newton to push the box. So he's helping the previous guy, and he's also pushing the box on the right side with the same force. Okay, we'll just assume that they're pushing on the right side. You do it on the left side, it doesn't make any difference. At the same time, there's frictional force as well. And we understand that the frictional force acts opposite to the direction of motion. So if you're applying the force on the right side, then the frictional force would act on the left side, because frictional force is a resistive force. Now, there are 2 forces that are being applied on the right side. So on the right side, the total forces are 60 Newton. On the left side, the total force is 10 Newton. What is the overall force acting on the box? It would be the difference of 60 and 10. You subtract 60 and 10, then you would get the resultant force. So I can write that the resultant force is not 40, not 20, not 10, rather it is 50 Newton. and the mass of the box is given in the very first line, 2 kilograms. Then you need to find acceleration. You can apply the formula resultant force, which is 50 over mass was 2. The answer would be 25 meter per second square. Now once again, why do we use that concept whenever you're given with a set of forces, more than one force, and the forces are acting in different directions? So all you got to do is you have to first find the resultant force by taking all the forces into consideration, and thereby after doing that you can apply this simple formula A equals to F resultant over M, and that gives you the value of acceleration. Alright everyone, so let's move on to the next type 5. This one of the easier ones. Sometimes you're given with a velocity time graph or speed time graph, and from the graph they ask you to find the acceleration. And in this special case, the graph that you would be given is a straight line. That implies that the object has a constant or uniform acceleration. So in this one, type 5, all you got to do is you have to find the gradient of that straight line, and that corresponds to the acceleration of the object. So find gradient of the line, straight line, to find acceleration. Once again, applicable for velocity time graph or speed time graph. Velocity and speed in that context is just the same thing because we assume that the object travels in a straight line. Now, the very simple way of calculating the gradient is you use the formula rise over run. Alright, so rise means the vertical distance, like this one, the vertical distance, and run means the horizontal distance after you have chosen any 2 points. So what I'm going to do is I'm going to choose 2 points on the graph, and the first point I can choose this one, the second one is this one. Now what is the vertical distance between these 2 points? So it starts from 0 and vertically it ends at 12. So the rise in that case is 12. Now run implies the horizontal distance. The horizontal distance between these 2 points is 4. So that gives you the gradient, and the gradient in that case represents acceleration. Alright, and from there, by using the same fact, they ask you sometimes a question. So there's an other object whose velocity time graph looks like this. I say this, and they ask you object A, compare object A and object B. Which object has more acceleration? Actually may not be labeled. All you would know is it is velocity time graph, and they simply ask you compare the acceleration of object A and object B. Which object has more acceleration? So without doing anything, you simply identify that uh, object B, the graph of object B has more acceleration because the line is more tilted, right? It is more closer, it is closer to the y-axis, all right? It is towards the y-axis more compared to the object A. So that's why we can say that object B has more acceleration without actually calculating the acceleration of any of the two objects. So that was your type 5. Alright everyone, now let's move on to the type 6, which can be considered as an extension of type 5 because this is also related to the velocity time graph or speed time graph. But the catch here is that the graph is not a straight line, which then implies that the acceleration of the object is not uniform. Means at different instants of time, the acceleration of the object would be different. Now the question is, if the object does not have a fixed acceleration, then how can we find the acceleration? Or how would we know that at what stage do we need to find the acceleration? And the answer is obviously they'll mention in the question, they'll specify the instant of time at which you need to find the acceleration. Because if the graph is a curve, speed time graph is a curve, that implies its acceleration is changing. So you would have to find acceleration at a specific instant of time, which in that case is like 4 seconds. All right, so what you do in that one is draw a tangent to the curve at the given point. And then find, and then it's just the previous step, find gradient of that straight line. From there it's just the same step. So the only tricky part is to find to draw the tangent at that given time. So you see in the question they simply say determine the acceleration of the rock at t equals 4 seconds and state the unit. So first of all, at 4 seconds you draw a tangent. So you draw a straight line that should touch the curve at 4 seconds only and know the point. So might be a little bit tricky for me here on computer. Once you're doing it on the paper, it's not difficult at all. All right, so I assume that this line is touching the only this point at 4 seconds. All right, what is the next step? The next step is find the gradient of this straight line. It is now a question of mathematics. How can you find gradient of this straight line? Well, plenty of ways. You can use rise over run. After choosing two different points on the straight line, you can apply the formula rise over run. Or you can just choose any 2 points on this line and then you can apply the formula, the standard formula of the gradient. So let's say I've chosen these 2 points. Let's call it 2, First point is 222. The second, from x-axis we get 6, and from y-axis we get something like 42. All right, 222, 642. So these are the points that I have chosen from here. Now finding gradient once you have 2 points is not difficult at all. So 222, this was my first point. You can choose any 2 points, okay, but make sure the points are not too close to each other. There should be like reasonable distance. Reasonable distance. This was the second point, and then you can call this one x1, this one can be called y1, x2, this one can be called y2. Then you write down the formula of gradient, y2 minus y1. This is what we study in mathematics as well. X2 minus x1. And whenever they give you a question that is related to a curve and you need to find the acceleration, they don't expect like a very specific answer from you. The answer is accepted in a certain range, because at this stage dealing with the curves and finding the gradient might be a little bit tricky. So there's always a chance of an error. So that's why they accept an answer within a certain range. And obviously, if your answer is dramatically different, you'll be penalized. Otherwise, if your answer falls in that range, it would be totally fine. So 42 y2 minus 22 over 6 minus 2. Then we don't even need calculator for that. It would be 20 over 4. That would be 5 ms minus 2. So this is how we can find acceleration in type 6, where you're provided with a curve and they ask you to find acceleration. You simply draw a tangent at that specific point. Once you have drawn the tangent, it is just a question of mathematics of finding gradient of that tangent. All right, type number 7. From now on, pretty much all the types that I'll be explaining here, in those one, you need to state the acceleration. Not supposed to really calculate it or determine it. You need to state the acceleration. And when the question is state, it means information. Just reading the information should be enough to come to the right answer. You don't need to like solve it separately. Now, when the object reaches the terminal velocity, in that case, whenever an object reaches the terminal velocity, its acceleration would be 0. So first I'll write it down here. At terminal velocity, acceleration is 0. Right now I'm not going into the details of terminal velocity, but just for a reference, what you can think about it is terminal velocity is a stage, or it is a velocity at a stage where there is no resultant force. The weight and the air resistance of a free-falling object becomes equal to each other, hence the resultant force is 0. And in that case, the acceleration would also be 0, because if the force is 0 and you apply the formula A equals F over m, And like I said, F represents the resultant force, and if the resultant force is 0, so 0 divided by anything, the answer would be 0. So at terminal velocity, acceleration of an object is 0. Alright, just keep in your mind, memorize it as a fact. Obviously, we explain the details when we are introducing the concept of terminal velocity, but right now that is not the purpose of the video. So all I can tell is at terminal velocity, the weight of an object and the air resistance acting on it becomes equal to each other. They cancel out, net force is 0, and hence there's no net force, so there would be no acceleration. So at terminal velocity, the acceleration is 0. Just before reaching the terminal velocity, the acceleration would be almost 0. All right, so you can think about it. Let's say this is a starting state and the object reaches a terminal velocity over here. Terminal velocity reached over here. So exactly on the terminal velocity, acceleration would be 0. In right over here, acceleration would be 0. Over here, acceleration would be maximum. Over here, acceleration would be half of the maximum value. Over here, acceleration would be almost 0. It might be 0.1, 0.2, almost 0. So as you're approaching, as you're moving towards the terminal velocity, the acceleration is decreasing. And at terminal velocity, it eventually reduces to 0. Now take a look at the question once again. An object falls from rest through the air and the air resistance on it increases. The object reaches terminal velocity. Which quantity decreases until its terminal velocity is reached? Acceleration. Until the terminal velocity is reached, acceleration decreases, and when the terminal velocity is reached, acceleration reduces to 0. All right, let's move on to the next one. So 7 and 8, like, they are mirror images of each other. This can be called as the extension of the previous one. When an object moves with a constant velocity or with constant speed in a straight line, in that case, the resultant force acting on an object would be 0. So you can take a look at the image below. The car is moving to the left side and the driving force is 6,000 Newton. Car is moving at a constant speed and hence the frictional force equals the driving force, which is also 6,000 Newton, but it has to be in the opposite direction. Now what is the resultant force in that case? It would be 6,000 minus 6,000, because both the forces are in opposite directions, and forces being vector, opposite directions refer to the process of subtraction, and the resultant force is 0. Now if you try to find the acceleration, F resultant over m, your answer would be 0 over m, and eventually your answer would be 0. So when an object moves with a constant speed, constant velocity in a straight line, the acceleration would be 0. So once again, this is a kind of a question where they ask you to state the value of acceleration instead of saying calculate the value of acceleration, because you just have to recall the concept. Now if the object travels with a constant speed in a straight line or constant velocity, the acceleration would be 0. What's the reason? Because At that state, there's no net force because all the available forces cancel out each other. All right, on to type 9. Once again, this one is something that is related to facts and figures. You don't need to calculate something. You'll be asked to state, or you'll be just needed to circle the right answer just by interpreting the question without calculating it. Now, this statement says when gravitational field strength for a free falling body is given. So gravitational field strength is something that we introduce in chapter mass, weight and density. It is represented by the letter small g, and we say it is for the planet Earth. On the surface of the Earth, the value is Newton per kilogram. What does that represent? Gravitational field strength represents the amount of force that would be exerted on 1 kilogram object when it's placed on certain mass. Like in the case of Earth, if the object is placed on the surface of the Earth, then it would experience a force of 9.8 Newton for its 1 kilogram mass. Now, if they state the value of gravitational field strength in the statement, and they ask you what would be the value of acceleration. So gravitational field strength given, and let's say nothing else is given in the data, and they simply ask you what would be the value of gravitational acceleration or acceleration. The answer is whatever the value of gravitational field strength is, that would be the same as the value of acceleration. Or the question can be asked in either way. Sometimes they give you the value of acceleration and they ask you to find the value of gravitational field strength. Like in this one, you can see the acceleration of the free falling body for the vertical motion is given as 1.6. They ask you to find gravitational field strength. So it would be just the same. The only difference is gravitational field strength is measured in Newton per kilogram and acceleration is measured in meter per second square. But in terms of magnitude, it would be just the same thing. Right? So once again, the question can be asked in either way. Gravitational field strength is given, you have to state the acceleration for free fall. Free fall acceleration is given, you need to state the value of gravitational field strength. And you see this mass that they had given in the question was pretty much of no use. All right. When the object is moving in a circular path or when the object is moving in a circle, in that case, its acceleration is called as centripetal acceleration. When an object is moving in a circle, its acceleration is called centripetal acceleration. And related to circular motion, the things that you can be asked about acceleration is, I'm going to write it down. All right, once again, the topic for today is not to explain the circular motion, which I might be doing in some other video, but right now we are confining ourselves to the problems related to acceleration. So the first thing or the first fact that you have to keep in your mind when they ask you about circular motion is acceleration is directed, and its direction is towards center of the circle. Center of what circle? The circle in which the object is moving. So if the object is moving in a circle, its acceleration is nicknamed as centripetal acceleration, and that acceleration is directed towards the center of the circle. So let's say the object right now is at this position, and they ask you where is the acceleration of the object. Direction A, direction B, direction C, or direction D. And the answer would be direction D. Why? Because direction D represents the direction towards the center of the circle. The next thing that you need to remember from here is this acceleration or the centripetal acceleration is there even if object moves with a constant speed. Because acceleration is defined as the rate of change of velocity. And I said that we can assume that acceleration equals rate of change of speed, provided the object travels in a straight line. The direction of the motion does not change. But for the fact when the object is moving in a circle, its direction changes at every point on the circle. So that's why the acceleration exists even if the object moves with a constant speed. So let's say the object was moving with a constant speed 30 meters per second in a circle. So will the object be accelerating? And the answer would be yes. The acceleration is there. Even the speed is constant. Even if the speed is constant, but the thing is velocity is not constant, because velocity takes account of the direction as well. And if the object is changing its direction, so velocity changes, and if the velocity changes, the acceleration would be there. And the final thing that you need to consider here is if that acceleration is constant or not. In terms of the magnitude, that acceleration for an object moving in a circle, or we can say the centripetal acceleration, is constant in terms of magnitude. Means if the value of acceleration that you calculated, the formula for calculating the acceleration is not part of O levels. Study that in A levels. So right now I'm not going to come up with the formula, but let's suppose that the centripetal acceleration that you calculated is 2 meters per second square. Now in terms of the magnitude, it will remain 2 meters per second square, but in terms of direction, the acceleration would be different, so not constant. You can say non-uniform, not constant, changing, variable, use any word. Non-uniform. Since acceleration, being a vector quantity, takes account of magnitude as well as direction. So they ask you about a general statement that object travels in a circle at a constant speed. Will its acceleration be constant or variable? So we simply say its acceleration would be variable or non-uniform, because although in terms of magnitude only it is constant, but that's not it. Acceleration takes account of direction as well, because it's a vector quantity. So overall the acceleration would be non-uniform. Now the last one, acceleration and deceleration. So acceleration is generally seen as change in velocity with respect to or per unit time. Change in velocity over time. Now the change can be positive or negative. Your velocity might be increasing or it may actually be decreased as well. So if the velocity is being decreased, then we nickname that acceleration as deceleration. So deceleration would tell you the rate of decrease in velocity, or how quickly, in simple words, in layman terms, I can say deceleration corresponds to how quickly your speed or your velocity is being decreased, how quickly you slow down. Rate of decrease of velocity. All right, and basically one thing that you need to consider is deceleration is considered as a special kind of acceleration. It's not a different thing. It's not acceleration is something else and then deceleration is something else. No, this is one of the confusing part. I see many of the students, they're struggling with this part. They assume that deceleration is a different thing. I generally like to present it with an analogy. I tell the students that you can think about it. So we say a man has to keep his promises. All right. So when we say man has to keep his promises, we're referring to a man. We're referring to a woman. It can be anyone. It can be a boy. It can be a girl. It can be an old man, an old woman. It can be anyone. A man has to keep his promises. The man, the word man there is representing both the genders, or I should say all the genders. So same is the case of acceleration. When we say the object is accelerating, now acceleration can be of two different ways. The velocity can be increasing or the velocity might be decreasing. And if the velocity is being increased, we simply call it acceleration. And if the velocity is being decreased, we call it deceleration. So you see, just like we can use man as a word that represents both the genders, well, all the genders or every gender. I don't want to start the debate about the extra genders and stuff. So man represents all the genders, but if you're referring to male, we have to again use the word man. So acceleration, it can be representing increase in velocity or decrease in velocity, but once we are referring to increase in velocity, we once again call it acceleration. But if we are referring to decrease in velocity, we call it deceleration. Now the thing is, if you're asked to find deceleration, you simply find acceleration and then change the sign of it. So deceleration equals negative of acceleration. So let's solve the question. They say a car is brought to a rest, final velocity 0 in 5 seconds from a speed of 10 meter per second. The starting speed was 10 meter per second. What is the average deceleration? All right, forget about deceleration. Let's find the acceleration. Acceleration equals v minus u divided by t, and v is 0 minus t was 10 divided by 5, and this one would be negative 10 over 5, which would be minus 2 meter per second square. What do we get? We get acceleration. But once again, the question was not to find acceleration, we had to find deceleration. So like I said, change the sign of acceleration, that would give you deceleration. So from minus 2, you can reverse it to plus 2, and the answer for deceleration would be 2 meter per second square.